Hey guys, so for my inquiry, I chose to do magnetism because that's a fourth grade concept that I'll be covering. I usually cover it around February during the school year, so by that point, students should have a pretty solid understanding of the inquiry process. So for an overview of the activity, this would be a multi-day activity. We would start with exploring with one magnet and a baggie of materials, some being magnetic, some being non-magnetic. The students would be sorting them, followed by the students exploring with two magnets and kind of seeing that connection between the two magnets, like what happens with them. After we did that and we shared out, students would be choosing a research question that would be approved by me. They would create a plan with their group, which would be 3 to 4 students. They would then follow an investigation. They would share out their results. And then at the end, I would make sure that all the main ideas had been covered. And if they hadn't, I would make sure to cover anything that, we still needed. But again, I'm treating this as if my students have been through the inquiry process and are pretty comfortable with that process. These are examples of the student handouts that I would use. I'm going to keep going because I have those posted on my discussion board. So the materials, I'm not going to read through these, and this is not an exhaustive list, but you just want to make sure that some of the materials would be magnetic while others would not be magnetic. The first part of this would be exploring with just one magnet. The students would have the baggie of the materials, magnetic, things that were magnetic, things that weren't magnetic. They could kind of group them. And then as they're doing that, they would have a T-chart and they'd be talking about or writing down things that they're noticing and things that they're wondering as they're making these two groups of magnetic versus non-magnetic. And then they would share out after they had done that, and I would write down any observations on the board for everybody to see. The second part of that then would be to pass out second magnet to each kid, and their job now would be to kind of explore what happens with these two magnets together. They could still use the other materials, but their main thing is to see kind of that relationship between two magnets. Again, they're going to write down things they notice, things they wonder. They're going to share them out, and I'm going to be writing those on the board as well for everybody to see. So after we did that, what we would do next is, based off that list that I've created on the board, students would choose a question to explore that would have to be approved by me, and that would be able to be answered based on the time resources that are available to them. So they would work with their group then to discuss ideas of how they would go about making a plan to answer their question, and then journaling their question, their steps, and anything else that they might need, like materials. Again, the level of teacher involvement is really going to rely on the students' comfortability with inquiry. So an example question of what students could answer is, why do magnets sometimes pull together or sometimes push apart? So during the investigation, students are using their chosen materials, they're following their plan and revising as they go, because we know things are never perfect the first time you do them. They're journaling by filling out the student handout that I made. And then I put a little note here, if students are answering the question about the poles, that sample question that I gave, and they've already identified that there's two different sides to a magnet, you could suggest something like, I could say like, here's a sticker that you can place on one side and a blue you could place on the other, so they can start to kind of like label the sides of their magnet to go a little bit deeper. These are just examples of pictures I found to kind of support like the north side and the south side of the magnet. Don't have the actual materials, so I couldn't show myself doing them. I don't have access to my building right now. So the alignment with STEM practice, science, they're studying magnetism, so the science is here. Technology, they could further their understanding through doing research, maybe once they've answered their question or if they need additional help. They also go filling out their student handouts on Google Slides through Classroom, because that really cuts down on paper. Engineering, depending on their question, they might be building something. For example, putting things in between magnets to see if traction is broken by putting a certain amount of items in between two magnets. And then math, they're making predictions, understanding the relationship between the positive and negative sides, repelling versus attracting. It could be comparing sizes of magnets to see like if one magnet's stronger due to size. And they're also sorting for magnetic versus non-magnetic. And then how this adheres to the tenets of inquiry. I chose to use two of the different charts that were in our readings. The top one was by Banshee and Bell, and I said that this level of inquiry would probably be a level 3 or a level 4 based on student needs. So I don't think one size is going to fit all here for inquiry, depending on the students that you have in your classroom. And then down here, I said, this was the one by Faye and Bretz. I said that it would probably be a level 2 or a level 3 because I could provide the question or problem to the students, but I think a lot of students would be able to choose. So thanks, guys.